G'day there, you're watching the Aussie BIM Guru. Today I've got a tutorial that you've probably seen other versions of before. If you've never seen an Al-Bahar adaptive facade tutorial, you've probably been living under a rock, but I thought I'd put my own take on it. So today we're going to look at an adaptive component in Revit. So I'd like to credit initially probably what seems to be the source for this workflow, or the pioneer. This is a pretty old tutorial. I believe it was maybe almost 10 years old now. Essentially it's Jeremy Rowe using Dynamo in order to analyze the facade by sun angle. Those that have been using Dynamo might know that Ladybug has not been working for a little while in higher versions of Revit. So I'm going to be using a little bit of Rhino inside in a later tutorial as well. But this is the first video that I used in order to learn about adaptive components in Revit. So it's a very important video to me in my learning journey. So I wanted to use this concept in order to repackage it into something you can follow, because this video is almost an hour long. And it does have a few aspects that I think Jeremy probably skims over, just because he's teaching a class where there's probably other components they've already taught. So I'm going to guide you through the process of building an adaptive panel. Now this is all based on a fairly famous facade, which has been around for quite a while now, the Al-Bahar facade. I believe it's in the Middle East somewhere, I probably should check that. But in this case, it is a responsive facade. So it's a kinetic facade, which means the panels can move. And in this case, it focuses on an aperture. Technically, it does say it's a hexagonal pattern. I believe that's in terms of how the panels are controlled. We're going to just approach them as individual triangular panels, just to simplify the process a little bit. So we're going to be using an adaptive component in order to control the opening and closing of these facade panels. So the workflow is that we're firstly going to build the actual triangular adaptive family, the panel itself, and we're then going to make an in-place mass where we're going to distribute a curtain panel that's there just to guide the placement of the adaptive panels themselves. And the reason why we're placing these separately is because anyone that's placed panels in a conceptual mass before might know that Dynamo doesn't have direct access to these panels in terms of their parameter values. So we're going to place them outside the mass in order to be able to access their data. And then in a later tutorial, we will actually use Grasshopper and Rhino inside plus Ladybug in order to control the opened and closed aspect of these panels. But we're going to focus mostly on building the panel in this tutorial. So without further ado, let's get started. I'm just going to jump into Revit 2020 and I'm going to make a new family. And in this case, I'm going to begin a generic model adaptive. So let's just have a quick think about how our panel works. So if we just have a look at one of these, we essentially have a triangular framework. So adaptive components work on the concept of points that control their placement. So in this case, we are going to have 1, 2, 3 points to dictate the placement. We're then going to frame a triangle around this, and we're going to find that rough center point of the triangle. We're going to assume that our triangles are typically going to be equilateral in shape as well. So we'll build our adaptive component in the shape of an equilateral triangle. In this case, we're also going to have to place a point that moves away from the center, and that's going to dictate the apex of the panel. From there, we constantly have edges back to the main corners, but then we have essentially points that will need to move along these inside edges from the outside edges. And on these 3 points, we're going to place a nested triangular adaptive subcomponent. Now, if none of that made sense to you, that's okay. By the end of this, hopefully you'll be able to follow what we're doing. So I'm just going to begin by going into floor plan. I'm going to place 1 point, and then I'm just going to copy at an angle of 60 degrees by 3000. I'm then going to copy across by 3000. So we've essentially just created an equilateral triangle. In this case, I'm going to start by making these points adaptive. So I'm going to go 1, 2, 3. This will dictate the placement order. In my case, I'm working on an anti-clockwise basis. So what I'm going to do is just select these points one at a time and just do a spline through points, just to connect these together. I'm then going to just select these all at once, and I'm going to tick on this isReferenceLine command, so that if we use these to generate geometry, the line still remains as something we can reference. Now the first thing I'm going to do is actually just probably center this triangle on my drawing environment, but the first thing I'll do is place a point. And I'm going to place it halfway along this curve. Notice the curve highlights when I do this. This means it's going to be hosted to the curve. And the way you can know that this is hosted to is the dot's a little bit smaller than a loose point. Notice the loose point's quite thick. So in this case, this is actually hosted, and it's being told to remain at the normalized curve parameter of 0.5. so halfway along the curve. And we're going to take advantage of normalized curve parameters quite a bit in this tutorial. They're very handy in adaptive components. So I'm just going to select these two lines now and join them with the spline. And likewise, I'm just going to find the center of each of these, and I'm going to join two of these together. And then I'm just going to draw a reference line. And in this case, I'm going to place another point on this line here, but instead of just leaving it where it is, I'm going to select it. I'm going to host this point by intersection. So I'm going to host by the intersection with this line. So now at this point, will always remain at that intersection, no matter what shape my triangle takes. From here, I can just connect this normalized parameter point with this intersection hosted point. There we go. So we now have most of the framework we're going to need to do the basics of what we're controlling here. What I'm also going to do is have to introduce a couple of extra points. Now, first of all, I'm actually going to add, another reference line here, just on top of the other one. And this is so I can work along this segment of the curve. We're going to do the same with our other segment. And just to keep things easy, we're going to hide these two major reference lines, because we're going to place a point along each of these that moves inwards, and that's what pinches the panel. So that's essentially how our panel is going to open. So I'm going to place 1 point, 2 point, 3 point. Let's just check that they're all working from the beginning of the curve. Notice in this case, this is actually at 0.84. So my reference line is actually the other way around. In this case, we're just going to say this is from the end instead, so that we're always referencing a constant direction in the case of each curve. I'm going to take these 3 points and I'm just going to associate a parameter to their normalized curve parameter. And I'm just going to, in this case, say this is the open factor, but I'll call this NCP for normalized curve parameter. I'm going to use a little formula just to make sure the panel's never fully open or fully closed. I'll make that an instance space parameter because every panel's different. And we now have a few points we can use to control our panel. So if we go back to 3D, we can see now we've got quite a good framework. We now need a point that moves away from the center point to form the apex of our panel. So I'm going to select this point. Notice I can see these work planes, but if I deselect it, they're gone. If I want to always see them, I can just select the point, go to Graphics, Show References, and I'll just say Always. And now we can always see the reference planes of this point. Now the reference plane we care about is this horizontal plane that we want to push a point away from. I'm going to create a point, and I'm firstly just going to set my work plane to that line, which essentially represents the plane of that point. I'm going to click once, and it will tell me there's identical points in the same place. That's fine. We're sort of like hosting a point on a point, if that makes sense. So as we push this first point away using our offset parameter, it should remain constantly on top of that point. So if I go and change, notice that it moves with it. So we now have a means of controlling the apex of our family as well. Let's just select the offset and associate a parameter with this. I'm just going to call this apex height. I'll make that instance based. And that's pretty much it. We have the framework. If it helps, you may wish to just add a little reference line going up to the apex. That way you can sort of visually understand the framework of your family when you're placing the nested 3-point triangles that we're going to use to place in our family. Now the first thing we might do is actually just establish the formula that controls this inset and this offset. So what we're going to need for this is a number that's going to control that relationship. And this will also be the number that we're going to use to control the aperture of the panel using computational software. I'm going to make a new parameter, and I'm just going to call this the open factor of the panel. So how open is that panel? I'm going to make it instance-based, and I'm going to make it a number. Now in this case, I'm going to say that the normalized curve parameter is obviously going to be equal between 0 and 1, but like I said, I never want to quite fully close or fully open the panel. So in this case, I could use a formula, or I could just use some tricks to do this. I believe in this case, I might just say that this is equal to, I'll say if open factor is less than 0.1, make it 0.1. Otherwise, if open factor is greater than 0.9, make it 0.9. Otherwise, make it open factor. That way, we're never exceeding or going less than 0.1 or 0.9. I'm going to copy this formula and just use the same sort of relationship in this case. So in this case, I'm going to say that my apex height is, say, going to be a meter when it's at its maximum, let's say. So in this case, I'm going to say that instead of 0.1, it's 0.1. It's going to be the result of this formula times 1,000. And now I have a means of controlling how open or closed the aperture is. So right now we have a pretty small open factor. We actually have an open factor of 0. We can see in this case that the aperture height is quite low and the inset is quite close to the edge of the panel. So the panel is going to be more closed. And as we increase that value, it's going to progressively climb higher. So let's say we want to go to 0.5. Now our points move along our curve to the halfway point, and our aperture is getting higher because of that formula. So you can see the way that the framework can be made to respond to one parameter. We're really quickly just going to make a new family. And in this case, I might just save this too, just to be safe. I'll just call this main panel. I'm going to make a new family. I'm going to make another generic model adaptive. I'm going to be very loose with this one. I'm just going to go click, click, click. Adaptive, adaptive, adaptive. So I'm being very quick here. I'm just making a 3-point family. Doesn't really matter on the shape that much, just that it's an adaptive framework that will form a triangle. So I'm going to make those reference lines. I'm going to create form, and I'm going to make this a solid form. I'm going to make the positive offset 0 and the negative offset -25, or actually just 25. And I'll associate a parameter to this, and this will be the thickness of my panel. Now I'm going to make this type-based, but I'm going to make sure that this family is not shared. That way, at the next level in our main panel, we can associate instance parameters to the type parameters of this panel definition. As well as this, I'm just going to assign a finish parameter to it. I'm going to add a material and just call this finish, and again, just a type basis in this case. I'm just going to save this family, and I'll just call this subpanel. I'll make a type and just call it typical. Now let's load this into our main panel. And we're going to be able to place these as nested panels. So it's prompting us to pick the first point. Now when I build a family like this, I usually like to try to make the first point the origin if possible. So in this case, I'm going to start placing them from the adaptive point first, the inward point second, the apex third. In this case, I'm going to go corner, apex. So I'm always drawing in the same direction. I'm drawing counterclockwise. That way the normal is facing downwards when I place the family, which is really important with adaptives. The placement order will dictate the orientation of the family. And I'm just placing them one by one. Now you could make these using more reference planes and some extrusions, but in this case I prefer to control everything from one component. It does mean the family is a little bit slower to receive change, but it's a much more stable and changeable system. So now we have some adaptive components. So I'm just going to go to the type properties. I'm just going to add a finish, and I'm just going to nest on a type basis the finish parameter. So because it wasn't a shared family, we're allowed to do this. I'll make the thickness 15, and then I'll just create a parameter called thickness on a type, sorry, type basis. Whoop. Cough, not a COVID cough, luckily. Okay, so at this point we have our panels. Now let's just try changing the values of our family. This is where it gets fun. So because these are all adaptive, they should move with everything else. So let's go 0.2 and check it out. It's an adaptive family, so pretty fun, right? So this is something that would almost be impossible in a typical Revit family. And remember that this family is still adaptive as well, so this family is also going to be adaptively placed, which is pretty cool. So this is where adaptive components become really special compared to other types of families. I'm just going to create a finish parameter as well. I'm just going to create a new material, and I'll just call this facade, and I'm just going to give this a color. So I'll replace this asset name with facade, and let's just make this a nice ugly shade of yellow, just to offend everyone. I'm also going to make the surface pattern that color as well. Typically you wouldn't do this in a BIM model, it's just to save a little bit of time and to avoid having to use realistic mode to see it in color. If we OK that, you can see that type parameter gets pushed down to the panel type definition, and now we have that color across the panel. Before I finish, I like to usually clean up the family a little bit, so I like to get rid of any unused fill patterns, which pretty much is all of them. I like to usually get rid of most line patterns, maybe retain the hidden pattern. Sometimes I even delete the hidden pattern, but do be mindful that the hidden pattern is typically used, or a hidden pattern is typically used for reference lines. So if you delete it at the wrong time, you're just going to get solid reference lines. So just keep that in mind. What I can also do, just to make my family a little bit easier to understand, is I can just select everything and move everything to the absolute center of the family. It doesn't actually impact the way the family is placed, it just might make the family a little bit easier to edit and understand. But in this case, the points are really what dictate how this family will behave when it's placed. As well as I might just go and delete the unused materials and give the family a little purge. So I'll just delete all of these and I'll just purge until there's nothing left to purge. So a very clean family. I believe I've made all the parameters I need, but I just need to rename this type to typical. And at that point, we have a panel that we can place conceptually. Now I'm also going to create a curtain panel as well. So there's no template for this as far as I'm aware, but if you go to Open Family, and you go down to the metric library, curtain panel by pattern, you should be able to copy a triangle bent surface panel. So in this case, I'm going to call this placement guide. And the only purpose of this panel is to sit inside a conceptual mass and tell Dynamo where the placement points for the actual component will go. So I'm going to open this panel, and all I'm going to do is I'm going to turn off this panel so we can't see it. In fact, you might even just be able to delete that element, to be honest. And I'm just going to create some model lines that I can see in order to influence the placement location of the panel. I'm going to select those 3 model lines I've just created, and I'm just going to make them only visible at coarse detail level. I'll make them invisible in all but 3D. That way we only see them when we really want to. Okay, so in this case, I'm just going to save my placement guide. In this case, just as a placement guide panel. Seems like it's having trouble saving. Okay. Interesting. There we go. Okay, it's giving me a read-only warning. Good old Windows. Let's just call this placement panel. That should make Windows happy for me working off the desktop. Okay, so at this point we have our panel, we have our placement guide. Now we need our facade. So we're going to make a new project. Doesn't matter really which template you use. I'm just going to use the good old Autodesk template. And we're just going to create an in-place conceptual mass. So I'm going to go to Component, Model in Place, and I'm just going to make a mass. And it's going to turn on Enable Mass, that's fine. We'll just call this facade. Doesn't really matter what you call it. And we're just going to draw a model line. We're going to just create a start-end radius arc. And I'm going to make it maybe 15 meters wide and just give it a little bit of curvature. I'm going to jump into 3D and I'm just going to create a solid form. And I'm going to constrain the top of this form to this level. I'm going to close the mass and I'll just make this go up to maybe say 25 meters. There we go. Now we can see that that's controlled by the level. I'm going to go back in and edit in place, but first I'm going to load in my placement guide. So I'm going to load this into the project. Whoops, not into the main panel, into the project. And we're in coarse detail at the moment, so we should be able to see them. So I'm going to go into my component again. I'm going to tab select until I get my surface, and I'm going to divide my surface. I'm going to divide it, and I'm going to be using the bent triangle pattern, but notice we'll end up with the panel that we've used from the curtain panel by pattern. So I'm going to say placement panel solid, and in this case we might need to turn on our pattern as well. Now we can see our pattern, and we can just dictate the spacing or the rules for the placement of our system. Let's say the maximum spacing is how we want to do this. And we'll just say 3000 by 2000, which should give us not quite an equilateral system actually. Maybe, yeah, we don't quite want that. That's probably a little bit closer to an equilateral system, I think. Pretty close. So we'll work with that. Okay, so we're going to finish mass. We're now going to load in our adaptive component. Now, how do we place it in the actual facade itself is the question. So you could obviously go 1, 2, 3 and do them over and over again. Now I did it the wrong way around just to show you why placement order is important, because in this case you can see I did 1, 2, 3, which faces it the wrong way. So if I did actually want to place this panel properly, I would need to draw it in the order that it's modeled. Notice in this case, it turns the other way around, which is perfect. So what I'm going to do is actually use Dynamo instead. So it's a really small little script, a very simple script. I'm going to go manage Dynamo. And in this case, I'm going to be finding all the instances of those guide panels and then placing an adaptive component by points around these elements. Now remember that we have 3 lines inside our panels as geometry, which we're going to take advantage of. So in this case, I'm going to get my family types using a family type node. I'm going to go and get this placement panel somewhere down here. Yep, placement panel, solid. I'm going to call on the family instances. So I'm going to go family instance by family type. And somewhere in here, there we go. We can get all family instances of that placement panel. I'm now going to get the geometry of these elements, which is why I wanted to take out the solid geometry originally. The moment we get empty lists, because I don't believe we can see those lines, so I might just go and double check the visibility conditions placed on these lines. Yeah, of course. To be honest, I'll just put them on under all circumstances so we can always see them. Just for now, because it seems like there's some setting in my model that's not playing ball with me. So we'll load this back in. Now we should be able to see them. Yeah, there we go. Now we can see the placement lines. And if I rerun this, now we can see every panel is going to return us 3 lines essentially. Now these may not be in an order going around the panel in a clockwise or anti-clockwise fashion. I'm going to turn these into polycurves because joining curves into polycurves forces them into a circular order. But then I'm just going to take those curves back out of the polycurve once it's created. This is a little handy trick you can use to reorder curves into a logical order. And now the curves should be in a logical order, and we can now take the start point of each of those. So now we get the 3 points that represent each of those panels essentially. And we can use these to place an adaptive component. So I'm going to go and just copy another family types node. And instead, I'm going to find my adaptive panel. So I'm going to find main panel. And I might go to manual mode here and just save my Dynamo script. I'll just call this placement. So I'm going to be looking for the adaptive component by points node, and it expects a sublist of points with the same number of points as the placement point count in the adaptive component. In this case, 3 points per panel, which we have, and then a panel with 3 adaptive points each. I think by default it should be longest lacing. So I'll feed in my sublists, feed in my adaptive component, go back to my model, and run. And we should expect to see 1 adaptive component per guided placement point. And at that point, we've essentially successfully placed our component, which is great. So what you can do now is just turn off the mass. We don't care about that anymore. And maybe you want to turn off the curtain panels for placement as well. Now you could just actually delete the mass. You don't actually need the mass to still be visible. What we might need to do is go to massing and site and show mass by view settings. There we go. And there you go, you can see we've now placed a relatively complex component. Now we still haven't found a way to change the aperture of the panels, but we're going to be using computation in the next part to do this. Now the logic here is we're just going to go and find the incidence of the panel to the sun, and we're going to populate that value back into the panel. And you can see now that we have the ability to do this, which is pretty exciting. And because we've placed them all outside the conceptual mass, we have independent control over all of these panels. Whereas in a conceptual mass, if you use the repeater component, you don't have individual control and you don't have direct access into their parameters using computational software. So hopefully that helps you get started with a pretty exciting facade and a pretty fun workflow, and maybe you can pick a more exciting form than what I've used to distribute the panels. Just make sure it's a roughly equilateral spacing. So hopefully you found that interesting. The files will be on GitHub, and in the next part we'll have a look at using Rhino inside to compare the angle of the sun to the incident angle of the panels and use that to control the aperture. So thanks for watching. If you're not already following and subscribing, feel free to do so, and I look forward to seeing you in future videos. Thanks. Take care. Bye.